Right now, as you are watching this, your Toyota is drinking oil. Not leaking it onto your driveway where you could see it, not burning it in a cloud of white smoke that would tip you off immediately, but silently, invisibly consuming it deep inside the engine where you will never notice until the damage is already catastrophic and irreversible. If you own a Toyota Camry, a RAV4, a Scion TC, or any vehicle powered by the 2.4-liter 2AZ FE engine built between 2002 and 2011, stop what you are doing and pay absolute attention to what I am about to tell you, because the dealership has a script ready for you. They have rehearsed it. They have trained their service advisors to deliver it with a calm, reassuring smile. And that script is designed to do one single thing: move you as smoothly and as quickly as possible toward a $4,000 engine rebuild that you absolutely, 100%, do not need. The phrase they will use is normal oil consumption. They will tell you that burning a quart of oil every 1,000 miles is simply what older engines do. They will say it with total confidence, as if it is a law of physics, as if Isaac Newton himself wrote it down somewhere. And millions of Toyota owners every single year hear that sentence, nod their heads, accept it, and start budgeting for an engine teardown. What those owners do not know, what the dealership is counting on them never finding out, is that Toyota's own engineers identified this problem, documented it in precise technical language, and quietly circulated an internal bulletin about it years before your service advisor was even hired. The solution was never a rebuild. It was never $4,000. The solution costs $15 and takes about 12 hours of doing absolutely nothing. That is the secret they have been hiding, and by the time this video is over, you will understand exactly why they hid it and exactly what to do about it today. To understand the scam, you have to understand what piston rings actually do, because this is where the deception begins, at the level of pure mechanical physics. Inside your engine, 4 pistons travel up and down inside 4 cylinders thousands of times every single minute. Each piston is ringed by a set of thin metal bands, typically 3 of them, seated in grooves machined into the outer wall of the piston itself. The top 2 rings are compression rings. Their entire purpose is to form an airtight seal between the piston and the cylinder wall, containing the explosive force of combustion above the piston and converting it into rotational energy. Without that seal, the explosion simply bleeds past the piston, power drops, and the engine becomes inefficient. But the third ring is the one that matters most for this conversation. It is called the oil control ring, and its job is fundamentally different. While the upper rings seal combustion gases in, the oil control ring's job is to scrape excess engine oil off the cylinder walls on the downstroke and push that oil back down through small holes drilled into the piston itself, returning it to the oil pan below. Think of it like a tiny squeegee on a glass skyscraper window, pushing water back down into a gutter at the bottom. The system is elegant. The cylinder walls need a microscopic film of oil to prevent metal-on-metal friction and catastrophic wear. But if too much oil accumulates on those walls, the combustion ring cannot contain it, and raw oil gets pulled up into the combustion chamber where it burns, producing that distinctive blue-gray smoke and causing your oil level to mysteriously drop between changes. Now here is where Toyota's 2AZ FE engine has a design flaw that borders on criminal negligence. The oil return holes drilled into the pistons of this specific engine were engineered with a diameter that is, by any reasonable mechanical standard, too small. In competing engine designs from the same era, the oil return passages are wider, more numerous, and positioned at angles that use gravity and crankcase pressure more effectively. Toyota's design used narrow passages that work adequately when the engine is new and the oil is perfectly clean. But as any mechanical engineer will tell you, an internal combustion engine is a carbon-generating machine. Every single combustion cycle produces microscopic particles of soot, unburned fuel residue, and oxidized oil byproducts. In a well-designed system, these particles are carried away by the oil and trapped in the filter. In the 2AZFE, a significant portion of these carbon particles migrate into those narrow oil return holes in the piston and begin to accumulate. The process is slow at first, almost undetectable. Over 20,000, 30,000, 40,000 miles, a layer of hardened carbon lacquer builds up inside those holes like plaque in a human artery. The oil control ring, which depends entirely on those passages being open to drain the oil it scrapes from the cylinder walls, begins to lose its ability to function. The oil it collects has nowhere to go. It pools in the ring groove. It begins to contact the hot cylinder wall in volumes beyond what the combustion rings can contain. And silently, gradually, your engine starts consuming oil. 1 quart every 2,000 miles at first. Then 1 quart every 1,500. Then 1 quart every 1,000 miles. And when you bring it to the dealership at that point, they look at your mileage, they look at your service history, and they deliver that rehearsed line with a perfectly straight face. Normal oil consumption for an engine with this many miles. What they are not telling you is that Toyota's own engineers were watching this exact failure pattern develop across their fleet in real time. By the late 2000s, customer complaints about oil consumption in 2AZ, FE-powered vehicles had become impossible to ignore. Toyota's technical teams issued a technical service bulletin, a document type that in the automotive industry represents the manufacturer's formal acknowledgement that a specific reproducible fault exists in a specific population of vehicles. TSB, e.g., 00703, and the documents that followed it in the early 2010s laid out the oil consumption issue with clinical precision. They described the piston ring carbon clogging mechanism. They described the diagnostic protocol. And critically, they described approved repair procedures. But here is where the corporate machinery took over. A technical service bulletin is not a recall. A recall is public. A recall is mandatory. A recall means Toyota absorbs the cost. A TSB is an internal dealer communication. It tells the dealer technicians what is happening and what to do about it, but it does not automatically trigger a free repair for every affected owner. It triggers a warranty claim process. And warranty claim processes have rules, specifically about vehicle age and mileage. Toyota's dealership network, whether through direct instruction or simple financial self-interest, adopted a consistent strategy with these claims. When owners came in with low mileage and fresh warranties, service advisors would document the consumption, tell the customer it was within acceptable parameters, and send them home. They would do this at multiple visits. They would build a paper trail showing the consumption was documented and disclosed, which in warranty law is critically important. By the time the consumption became severe enough that the customer demanded action, the vehicle was almost inevitably outside the warranty window. And at that point, the conversation shifted immediately from warranty repair to a customer pay engine rebuild estimate, typically ranging from $3,500 to $4,500, depending on the market. This was not an accident. This was a pipeline. Millions of 2AZ FE-powered vehicles moving through their ownership cycles. Their owners systematically misinformed. Their warranty windows strategically exhausted, feeding a continuous, self-renewing stream of engine replacement revenue into dealership service departments across the country. Toyota's warranty costs stayed manageable. Dealership labor margins stayed healthy, and Toyota owners spent $4,000 fixing a problem that, at its mechanical root, was caused by carbon deposits in holes smaller than the diameter of a pencil lead. Now I want to talk about what commercial fleets discovered, because this is where the undeniable proof lives. Long-haul trucking operations and large corporate vehicle fleets operate under an economic logic that is completely different from the individual consumer. Every dollar of maintenance expense is tracked, analyzed, and benchmarked. Fleet maintenance managers do not accept phrases like normal consumption. They run oil analysis on every engine at every service interval. They track consumption per 1,000 miles with the precision of a laboratory. And when 2AZ FE-powered fleet vehicles began showing the same consumption curves that retail customers were experiencing, these fleet operators did not go to dealerships. They went to their own mechanics and their own chemical suppliers, two plies, and they started experimenting. The compound that emerged from this industrial experimentation as the most effective solution is a class of fuel system and combustion chamber cleaners built around polyethyramine, commonly abbreviated as PEA. Polyethyramine is a chemical solvent that was originally developed for use in fuel injector cleaning applications. Its molecular structure allows it to bond with and dissolve the specific type of hardened carbon lacquer that forms on metal surfaces inside combustion environments. It is aggressive enough to break down deposits that have been baking onto metal at high temperatures for years, but it is not corrosive to aluminum or steel in the concentrations used for automotive applications. Fleet maintenance teams began using high-concentration PEA solutions not in the fuel tank, but directly in the cylinders, as a soak treatment. The results, documented across multiple fleet operators managing thousands of vehicles, were dramatic and reproducible. Oil consumption rates in treated 2AZ FE engines dropped by 60 to 80% after a single treatment. Compression readings, measurable with a simple gauge through the spark plug hole, improved by 15 to 25 psi in affected cylinders. Engines that had been consuming a quart of oil every 800 miles were, after treatment, consuming a quart every 4,000 to 5,000 miles, which is well within normal operating parameters for any engine. This data was not published in automotive magazines. It was not broadcast on manufacturer websites. It circulated through fleet maintenance networks, through independent mechanic forums, through the kind of word-of-mouth technical community that the dealership industry has no presence in and no interest in. Because this solution, which costs roughly $15 in materials and requires zero specialized tools and zero professional labor, completely destroys the $4,000 rebuild revenue stream. Here is exactly what you need to do, and I want you to follow this precisely because the sequence and the timing matter. First, go to any auto parts store, any large online retailer, or any automotive chemical supplier, and purchase a bottle of a high-concentration polyethyramine fuel system cleaner. The products that contain the highest PEA concentrations and are most effective for this application include Chevron Techron Concentrate Plus, which you can find in a 12-ounce bottle, and BG44K, which comes in an 11-ounce aerosol can. You want the concentrate versions, not the diluted formulas marketed for regular fuel tank use. The price will be between $12 and $18, depending on your location and the supplier. This is your $15 fix. Before you begin, make sure your engine is cold. Do not do this on a warm engine. Let it sit overnight if you drove it recently. because you are going to be pouring liquid into the combustion chambers and you want zero heat, zero pressure, and zero risk of any unexpected reaction. Open your hood, locate the 4 spark plug wire boots or coil-on plug coils on the top of the engine and remove them carefully. Then, using the appropriate socket, a 5/8 inch or 16 millimeter deep socket on a long extension, remove all 4 spark plugs and set them aside. What you will see when you look down into those spark plug holes, if your engine is affected, is the top of a piston covered in a brownish-black layer of hardened carbon deposit. This is the visual confirmation of everything I have described. That carbon is inside your oil return passages right now, choking your oil control rings. With the spark plugs out and the pistons visible, rotate your engine by hand, using a breaker bar on the crankshaft pulley bolt at the front of the engine until the piston in each cylinder is at the bottom of its stroke. You can feel and see this by watching down the plug hole with a small flashlight. Piston at the bottom means maximum space in the cylinder and maximum contact time between the solvent and the ring area when you pour. Once each piston is positioned at the bottom of its bore, pour approximately 2 to 3 ounces of the undiluted PEA concentrate directly into each cylinder through the spark plug hole. Do not be shy about it. You want the solvent pooling in the ring groove area, which is the region just below the top of the piston when it sits at bottom dead center. The chemical needs to reach those clogged oil return passages and sit against the hardened carbon deposits long enough to penetrate and dissolve them. Now you install the spark plugs back loosely, not fully torqued, just enough to keep debris out, and you walk away. You let the vehicle sit for a minimum of 8 hours. 12 hours is better. If you can leave it overnight, do that. The polyethylamine needs time to work its way into the carbon matrix, break the molecular bonds holding that lacquer together, and convert it from a hard, solid deposit into a soft, removable sludge. You cannot rush this step. The chemistry requires time and contact. When you come back, before you crank the engine, remove the spark plugs again, completely. Then fold a few layers of old rags or shop towels and hold them over each spark plug hole. Now, with the plugs out and the rags ready, disable your ignition system by pulling the main ignition fuse or disconnecting the ignition coil connectors, and crank the engine for 3 to 5 seconds using the starter motor. What will come blasting out of those spark plug holes under the force of the cranking compression is a mixture of dissolved carbon sludge, liquefied PEA solvent, and the debris of years of accumulated deposits. This will be brown, it will smell chemical, and it will spray with real force onto your rags. That is the carbon that was destroying your engine, leaving the system forever. Do this cranking, purge twice per cylinder, reposition the rags as needed, and when the discharge slows to a minimal drip, reinstall your spark plugs to their proper torque specification, reconnect your ignition system, and start the engine. It will run rough for the first 30 to 60 seconds as the last traces of solvent burn through the combustion chambers. Let it do this. Then drive it gently for 5 to 10 minutes to bring the engine fully up to temperature. Immediately perform a complete oil and filter change because the dissolved carbon and chemical residue that has been purged from the ring grooves will now be in your oil pan, and you need that contaminated oil out of the engine as soon as possible. Use a fresh conventional oil for this first post-treatment change, not synthetic, because you want to run the engine for 1,000 miles on the cheap conventional oil first to ensure all residual solvent has been fully expelled, and then switch back to your normal full synthetic on the subsequent change. The repair industry is watching content exactly like this and working to discredit it, to flag it, to bury it in search results. Because every single time a Toyota owner watches this video and spends $15 instead of $4,000, a service department loses a job ticket worth more than what most people spend on groceries in 2 months. They call this kind of information dangerous. They say it voids warranties, that it damages engines, that you should always trust a professional. What is actually dangerous is a corporation that engineered a known flaw into millions of engines, documented the flaw internally, and then systematically trained its dealer network to exploit the resulting failure for profit while stringing customers along on meaningless oil top-up schedules until the warranty clock ran out. Share this video right now with every person you know who drives a Camry, a RAV4, a Scion, or any vehicle with the 2AZ FE engine. Do not post it as a curiosity or as interesting content. Post it as a warning, because the person in your contact list who is currently being quoted $4,000 for an engine rebuild needs to see this before they sign that service authorization form. Subscribe and hit the notification bell, because the next video I'm releasing exposes something even more deeply buried than this. I have obtained internal documentation from a major American automaker showing that a specific brake fluid degradation issue, one that causes complete hydraulic failure in extreme braking scenarios, has been known to their engineering department since 2019 and was quietly reclassified from a safety recall to a routine maintenance item to avoid a federal investigation. The number of vehicles affected is in the millions, and the vehicles are on the road right now. You need to know which ones they